is all about traffic and the travelers, but the other side of the picture is also security, the interest of the residents. To operationalize this, we need to quantify. So these are the 4 scenarios we will be exploring. First, the all gates closed scenario. This is the pre-intervention of the local government enforce the pass-throughs inside the subdivision by the TMU or the traffic management unit. And the present scenario, the scenario 2 is they allowed pass-throughs, so that's the intervention. And scenario 3 is a hypothetical all gates open scenario. And scenario 4 is all gates closed, but we introduced a bypass road here. We got ADT data from the PWH, publicly accessible data that is available. We matched that with the space syntax measures that I have been studying, so it's just good to have that. And we found that integration or closeness centrality and choice or between the centrality to have the greatest R, Pearson's R or directionality, and actually significant, very significant p-values. And then we use that to do a linear regression. We got the unstandardized beta or the coefficients and intercepts. There's we also did collinearity. There's no there's accessibility. There's acceptable levels. Investigated crime data, but as said, the crime is an aggregate of the subdivisions. So we explored again the correlations, and the first run is in the left side. The second run is more explorations. So in the answer, we just estimated the crime and AEDT for every node. So just to recall, the nodes are here. So these are the 13 nodes, and for every scenario, they have different AADT and estimated crime.
So how do we determine the level of service among the 13 nodes? So what we need are the input data, which includes the traffic volume, which was calculated by Andro for the 13 nodes, and then we determine the row width and the number of lanes existing in the road network. Then after we have that input data, we'll be able to determine the equivalent PCU and road capacity based on the DPWH, or the Department of Public Works and Highways guidelines on traffic. And then we will be able to calculate the volume to capacity ratio by just dividing the equivalent PCU over the road capacity per node. And then from there, we will be able to determine the level of service, which is categorized by letters A to F.
The resulting payoff matrix is this for the natural movement. This so our question is, what if there's government intervention? So using the same formula, we tried to widen or ban some specific types of vehicles. So we had adjusted LOS based on those changes, the widening or the banning of types. So now with the adapted intervention, same processes, we have the corresponding crime and LOS. First, we have the raw values, and then we normalized based on what is preferable. So we did we checked for the Nash equilibrium. What is really preferred are the scenario 1 and 4, which is the closed gates. So there are no pass-throughs in the subdivision, and there should be an intervention. This one we added weight and normalized. So the ranking, the highest ranking is still the intervened scenario 1 and 4. Also our Nash equilibrium.
Okay.
And we also did the IFN prioritization, which is consistent but made natural scenario 1 not preferable.
Okay. And the result is?
So the winners are the really do an intervention and close up the gates if we are going to be objective.